In today's class, we're going to be looking at exponential equations. Exponential equations. Now, in exponential equations, we are going to look at some stuff very interestingly that are very interesting, ranging from an exponential function. Now, it's important before we look at the exponential equation that you know what an exponential function is. An exponential function is. An exponential function is defined by the formula f of x equals to a raised to power x. All right. An exponential function is defined by this. What that means now, where the input variable x occurs as an exponent. So a function in which the exponent, when I talk about the exponent, I mean the power or the index is a variable, gives you an exponential function. And the value of a is greater than 1. The value of a is greater than 1. Alright. Example, 2 raised to power x. Alright. 2 raised to power x, 3 raised to power x. This is an exponential function. This is an exponential function. So when we're talking about exponential equations, an exponential equation is an equation that contains an exponential function. So if I'm to define that better, all right, an exponential equation is an equation that has a variable in its exponent. An exponential equation is an equation that has a variable in its exponent. When I'm talking about exponent, remember, I'm referring to the power. An example of an exponential equation. Look at an example. If I look at something like 5 raised to power 2x minus 3 equals to 125, all right? This is an example of an exponential equation. So this will now become 5 raised to power 2x minus 3. Okay, let me put x minus 3x equals 125. 5 raised to power 2x minus 3x equals to 125. This is an example of an exponential equation. An example of an exponential equation. The next thing we're going to be looking at are problems on exponential equations. We're going to look at some problems in exponential equations, and we are going to trash it in a very interesting way. So the first problem on exponential equation is this. So 5 raised to power 2x plus 4 times 5 raised to power x plus 1 minus 125 equals to 0. So when you see an equation like this, we have to find the value of x. That is the variable in the exponent, the variable in the power, or the variable in the index. How are we going to go about this? It's simple. This can be rewritten as 5 raised to power x all squared. X times 2 is written as 2x plus 4 times. Remember that 5 raised to power x plus 1 is the same thing as 5 raised to power x times 5 raised to power 1 minus 125 equals to 0. From here, you would agree with me that I am seeing 5 raised to power x. I am seeing 5 raised to power x. This suggests something. Let y be equals to 5 raised to power x, equation 1. Now, don't forget this step because we are going to use this step at the end of this calculation. Let y equals 5 raised to power x. And if y is equals to 5 raised to power x, that means any place I see 5 raised to power x, I'm going to replace it with y. So this is y squared plus 4 times, I'm putting y times 5 raised to power 1, of course, is 5 minus 125 equals to 0. This is y squared plus 4 times y times 5. 4 times y, 4y times 5 is plus 20 y minus 125 equals to 0 equals to 0. From this point, you would note that this is a quadratic equation, and we're going to solve it quadratically. You can use factorization method, you can use the formula method, and you can use completing the square method. If you check the link in the comment section, it is going to take you to the video where this was solved, because I've handled this in my previous videos, so I'm not going to go over this again. So just check the link. We're going to see how the steps in solving this through factorization method or through formula method. You can try it yourself, because I won't go through that step. Let's proceed. So solving that equation, we will have two values of y as 5 and y as minus 25. Now at this point, we solve this factorization or completing the square or formula method. Recall that y was given as 5 raised to power x. So from this point, if y is equals to 5 raised to power x, remember equation 1, then when y is equals to 5, equation 1 becomes, look at equation 1, y equals to 5 raised to power x. Equation 1 will now become, in place of y, I'm going to put 5. In place of y, I'm going to put 5. So equation 1 becomes y is equals to 5 raised to power x. When y is 5, this is 5 is equals to 5 raised to power x. This 5 is something as 5 raised to power 1. The base is the same in the two sides of the equation, so that is going to cancel. The powers drop down from indices, and 1 is equals to x. And of course, you can see that x is equals to 1. X is equals to 1. Now, this is when y is equals to 5. Now, another possible value of y is equals to minus 125. So, when y is equals to minus 25, equation 1 becomes y equals to 5 raised to power x. That means y equals to 5 raised to power x. That means in place of y, I'm going to put minus 25 equals to 5 raised to power x. All right. So at this point, how am I going to simplify this with a base of 5 so that I will cancel the base? Now, it's not possible to express this as an indices. All right. What I mean is that 5 squared is not going to give you 25, and minus 5 squared, 5 squared is not going to give you minus 25, and minus 5 squared is not going to give you minus 25. So this is not possible. From there, because that is not possible, we can say that the solution for the second value of x is invalid. There is no valid solution for that. This is true because from our rule of logarithm, p is equals to q raised to power x. If p is equals to q raised to power x, then log p in base q is equals to x. How am I going to find x? X is something as saying, so if I say log of minus 25 in base 5, compare this. This is my p, this is my q, and this is my x. Log minus 25, my base is 5, that's q, equals to x. That means that x is equals to log into minus 25 in base 5. Yes. There is no solution for the logarithm of a negative number in any base. When a number is negative, the logarithm of that number, that negative number, does not exist, is invalid. It's not possible to evaluate that. This is why for this question, there is no valid solution. There is no valid solution. The solution is invalid. Now, the only valid solution is that when x is equals to 5, when y is equals to 5 rather, x is equals to 1. This is the only valid solution. The only valid solution. From there, we move to the second question. In the second question, you can see I'm having 4 raised to the power 2x minus 21 times 4 raised to the power x plus 8 is equal to 0. We're going to do the same thing we did previously. We look out for the exponential function. The exponential function here is 4 raised to the power 2x and 4 raised to the power x. But 4 raised to the power 2x can also be written as 4 raised to the power x all squared minus 21 times 4 raised to the power x plus 80 equals to 0. From there, we look forward for a repetition of any exponential function. 4 raised to the power x repeats itself, so we say let y equals to 4 raised to the power x. When y becomes 4 raised to the power x, substituting y, that means that this is y squared minus 21 times y plus 80 equals to 0. So this is y squared minus 21 y plus 80 equals to 0. This has become quadratic. And we're going to solve this quadratically. You can use factorization method, you can use formula method, you can use completing the square method. Any method that is most preferable to you. If you look at the link below, you would see a video on how this has been solved. Because as a matter of fact, when you solve this, you are going to have that y is equals to 5 and y is equals to 16. Right? How did you get that? Check the link in the comment section, you're going to see how that is solved. You can see from here that we are recalling the fact that y is 4 raised to the power x, that's equation 1. When y is 5, equation 1 will become y raised to the power 4x, 5 equal, y is equals to 4 raised to the power x is 5 equals to 4 raised to the power x. Remember from our rule of logarithm, this is something as saying log, because we cannot express 5 as in index form, alright? It's not so easy to do that. The index is going to be a decimal, alright? So this is going to be log 5 in base 4 is equal to x. That means that x is equals to log 5 in base 4. We can use a bit more advanced scientific calculator to evaluate this, alright? And we can also evaluate when y is equals to 16. We can say from equation 1, we are just going to put 16 inside there, and this becomes 16 equals to 4 raised to the power x. Of course, we can evaluate, express 16 in index form, and 16 is going to give us 4 squared. Why 4 squared? I hope you know that 2 raised to the power 4 will also give you 16. The reason why we cannot use 2 raised to the power 4 is because 2 will not give us the same base as 4. So it has to be the same base. So you can see that 4 squared equals to 4 raised to the power x. Alright. So the base cancels. So this is 2 equals to x. You can see that x is equals to 2. So in this case, x is equals to log 5 in base 4. This can be evaluated, alright? But you can just make your answer like this. It's still correct. And x is equals to 2. So in cases where you cannot evaluate a number in index form so easily, you apply the rule of logarithm, which I talked about in the previous question, right? This is a tip of the iceberg on exponential equations. Don't forget how I got these two values of y. Check the video in the comment section to take you there. See you in my next class.